Okay, so in this video we're going to look at some situations where we would use the quadratic formula in some real-life scenarios. First, so let's look at this example. It says a power tower at Valley Fair lifts its riders 250 feet in the air before dropping them. Suppose someone's shoe falls from their feet while they are at the top. If an object is dropped, its initial velocity is always going to be 0. Because if you remember this formula that we've talked about earlier in this chapter, we always had a value for the initial velocity, how fast the ball or object was traveling right before it was thrown, right before it was kicked. So in this case, there's no force behind the shoe. It's just being dropped. We're assuming that the person isn't kicking their feet or anything. If that was the case, then there would be an initial velocity. But here we're just assuming that they're just sitting there and for some reason their shoe falls off and drops to the ground. So we're going to start by setting up this equation in standard form. So it's going to be h equals half of g. G is going to be 32 feet per second since everything here is in feet. So half of g is 16. So this is going to be a negative. Don't forget it's negative 1/2 of g. And like I said, your initial velocity is 0, so there's not going to be a middle term here because 0 times t is nothing. Plus your initial height, so the shoe is dropping from a height of 250 feet. So we want to figure out how long it's going to take in part B. It says how many seconds does it take to hit the ground. So we're trying to find out what t is, and to figure out how we can figure this out is that when the ball hits the ground, the height is going to be 0. So if I look at this equation, 0 equals negative 16 t squared plus 250, you see that we have a parabola set equal to 0, so we can use the quadratic formula. So in this case, your A is negative 16, your B is 0, and your C is 250. So when I set this up, it's going to be h equals the opposite of b, which is just 0, plus or minus the square root of b squared, which is 0, minus 4 times a, which is a negative 16, times c, which is 250. All of that divided by 2a. A is negative 16, so it's divided by negative 32. So when you do this on your calculators, when we type in negative 4 times negative 16 times 250, you get 16,000. And when we take the square root of 16,000, approximately 126.5. So right now we would have 0 plus or minus 126.5, all divided by negative 32. Now let's think about this for a second. This is going to be a parabola pointing downwards, and it's dropping. So if this represents our parabola, here's the height at 250 feet. So the time that hits the ground is right here. Well, remember, it's a parabola, so there's going to be 2 X-intercepts. But we don't care about this one. We don't care about the negative time because there's no such thing about time being negative. So we're just focusing on this part of our graph. So in other words, I want to figure out there's going to be a positive and a negative answer here. Now you could find both of them if you want, or think logically about it. So this one, if I took 0 plus 126.5, I'd get a positive answer, 126.5. Divided by negative 32 would give me a negative answer. So that's what would give me the number I don't care about. Or if I take negative 126.5 divided by negative 32, that's going to give me a positive answer. And when you do that, you get approximately 4 seconds as your answer. So it would take just under 4 seconds for your shoe to hit the ground if you dropped it from the top of the power tower at Valley Fair. Now, if you want to try the next one, you can, but when I created the story problem, I forgot to give you an initial velocity. So if you do this one, use an initial velocity of, let's say, sitting at the top of the Ferris wheel at Valley Fair, where riders reach a height of 80 feet above the ground. A child throws its cup in the air, but it drops unhindered to the ground. So let's say that when the child throws his cup in the air, it's traveling at a rate of, let's just use, that's a child, so we'll say 15 feet per second. Okay, so why don't you guys, if you want to try this one, you can. And so pause the video and give it a shot, and then hit play when you're ready to check your answer. Okay, so what you should have done is you should have said that, notice that everything's in feet, so we're going to use, again, negative 16, because it's half of 32. t squared. Your initial velocity this time is 15 times t plus your initial height, which is 80 feet. So when we go to find when it hits the ground, our A is negative 16, our B is 15, and our C is 80. So to find your x-intercepts, to find what t equals, your time, it's going to be the opposite of b, so negative 15, plus or minus a square root of b squared, and 15, when you square it, is going to equal 225 minus 4a, which is negative 16, times c, which is 80. All divided by 2a, so it's going to be divided by negative 32. So when you simplify that under the radical, your answer is 5,345. And the square root of that is about 73.1, we'll say. So now negative 15 minus 7, or negative 15 plus 73.1 would give me a positive answer. Divided by negative 32 would be negative. So what I want to do is I want to use negative 15 minus 73.1 divided by negative 32, which gives me 2.75. So it would take about 2.75 seconds for it to hit the ground. So with that, I hope you understand how you can apply the quadratic formula to some real-life situations, and good luck on your assignment.